Hello. So we are back Thursday. That's my last day because tomorrow I'll be off. Next week I'll be off because the kids are on holiday. And today we have a job. We have a nice HP laptop. It's a HP. Let me see. HP model 15-N098SA. Yeah. It was booked in for no picture. Yeah. But the problem is you have to pay attention, especially when you restart the computer and you realize actually it is a picture but it's not backlight. I don't know if you can see. Yeah, you can see the clock here. Yeah. It is picture but not backlight. Yeah. So let's fix it. Let's see what can be wrong here. I'll try to open the screen. It's more easy instead of opening the laptop to check that 90 volts power rail. Yeah. So let's open the screen first. So on the screen we know we have 3.3 because already we seen the picture. So all what is supposed to be there is 19, the dim signal and the power on signal. Yeah, we made few videos about this, but let's see on this one, this HP laptop. I'm just curious what can be there. Can be a dead screen. Mm. So backlight and picture are two completely different things. Yeah. The connector is plugged in. We have the inverter here. Let's check the voltage on the inverter, not on the connector, the screen connector. Let's see. Let's see what we have there, yeah? Let me power up the laptop. The connector is plugged in, okay. Power on. Let's get a multimeter. And we have ground. And we have some plus here. Nothing. Nothing. Maybe it's no ground here. The laptop is on. Yeah, the laptop it is on. Enough. Okay, so we don't have 19. Yeah, this is a stupid fault. But what's the reason why we don't have 19? Why the 19 is dying? We do have 19 each. You can check on the screen connector. What? 19, you can see there? 19. 18.9, 19. So we have 19 on the screen connector, but not on the backlight circuit. So how this is possible? We have a screen fault. Do we have any fuse here? Fuse. No, I can't. Yes, I see one here. This one. Oh, that's stupid. So this here on the fuse we have 19, on the other side of the fuse we have 0. That's stupid. Let's come with the power supply 19 and see if we have any short on that power rail. Let's say 17 to be safe. Yeah. Minus, plus, and we do have a short. Wow. Okay, let's power off the laptop. Unplug the charger. You should always remove the battery when you remove the screen connector, yeah? Always. Now let's fix the screen. So in this case, the fuse is burned indeed. But it's burned because the power rail is shorted, yeah? So here is the connector and here is the fuse. You see this white thing? That's the fuse. Now if we are coming with the power and we have a limit, let's set up a limit on the power supply. Let's say 1 amp, because the resistance is quite high of the short or whatever is taking the power, and I don't want to burn anything. 1 amp limit, yeah? 1 amp limit, that's ground. You see all these are connected, you can't see, sorry. When you try to find ground, you see where are the most components connected. This is a capacitor, you can see it's connected to ground. These all are connected to ground. This is connected to ground. So here is ground. And here is plus after the fuse. So before the fuse, nothing. After the fuse, we have a short, you can see. So it's taking 1 amp because that's the limit. And 2.6 volts. The voltage get dropped to 2.6 volts. So we do have a short. Yeah? Let's say no short, like a very low resistance circuit. Yeah? So we know the 19 volts is going here. Okay, that's weird. That capacitor is looking weird. Let me check with the multimeter. Let's check with the multimeter. Diode mode. Let's see diode mode compare with the ground, yeah? So diode mode with the ground is not even short. Yeah? So our short is after a semiconductor, yeah? Same like on the iPhone board, you remember? So you see, just checking here is no short. If I check with ohm on ohm mode, it will get me nothing. Here and here, like 800 ohms. That's not short. And on the other side, nothing. So what I will do, I'll switch on the diode mode and I will follow the plus. I'll stick this here and we will follow the plus together to see where it's going, yeah? So the plus is going, let's see. The plus is going here. No, here, sorry. Here, no. It's not going here, it's going here. It is going here, 0, 0, you can see. 0, 0. So my 19 volts is coming here. And we have this cap. You know what? This cap is looking weird. Checking with this one and this one is looking weird. But let's do it logical, yeah? This to ground. Ah, is no short. Ah. So this capacitor is good. It's no problem. So it's coming the plus to this coil and from the coil to the chip. Okay, that's bad. What is diode is doing here? Diode is good. Okay, that's bad. Let's check the chip output. That's the chip output, the diode, yeah? So the plus is coming here, is coming on some pin. Okay, let's try and come with the power supply and see what is getting hot. Because something it will get hot. But that capacitor is good. Okay, so I connected, it's taking 1 amp. It's taking 1 amp. Wow, 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 wow. What's wrong there? Everything is hot here. Let's see. Coming with current. Whoa, it's not on this side, it's on the other side somewhere. It's smoking from the other side. But this diode is getting mad crazy like hot. But you know what? I can see smoke from the other side of the board. Let's go on the other side. Well, the other side we don't have anything here. No, on the other side we don't have components. No, so can't be. Cannot be from the other side. Okay, this is a tricky one. This is a tricky repair. So you know what I will do? I will lower the current because everything is getting too hot. Let's lower the current to 500 milliamps, 600, yeah. And let's try one more time. So on, off, on, off. You know what? That capacitor is funny. On, off, on, off. So what do you think? I can't see any reason why a capacitor it will get hot. I can't see why a capacitor will get hot. There is no reason. Let's take that capacitor out. The capacitor is out. Do we have short anymore? On, and it's not short. Okay. 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 You see, that's the case when you have a... Okay, the fuse. Sorry, I forgot the fuse. Let's make the fuse. The fuse is burned anyway. So now we don't have any short, so we can rebuild the fuse. Yeah. So you see the capacitors are dying everywhere, like even on the screen. The fuse is out. Now I'll stick there a proper calibrated fuse. Original one. I know people are going crazy when it's about replacing a fuse with a wire. But the fuse is a wire. A wire is a fuse. A fuse is a wire. Yeah. So the fuse is there and it's perfect. Let's feed the connector one more time. Yeah, let me repeat myself. Every time when you unplug the screen connector, be sure you took out the battery and the charger. Yeah, every time, with no exception. Yeah, don't be like me. The things can get very wrong. Okay, no picture. Wow. Oh yeah, we have backlight and picture. You see, that's that case when actually, you know, you can replace the screen. I understand that, but you can fix the screen, not necessarily replace the screen. It's no point replacing if you can fix it. It's so easy to say, you know what? Oh, it's the screen. Let's replace the screen. That's not from here. You know what I mean? So on the job price of this job, yeah, I can easily just replace the screen. Simple. It's not about money. You understand? It's not about money. It's about, you can fix it. Fix it. Just it's not about money. It's just about I can do it. So let's do it, or let's try to do it at least. Yeah. So this was an easy one actually. The signals for dim and yeah, you can see it's getting bright and dark, so it's still working fine. Yeah. But that cap, like one cap. Nah, it will be fine. It will be fine without that cap. Don't be sorry. It will be fine. You know how is with the caps. I told you every time it's same like with the car gas tank. It's always more. Even if you are on the, okay, 0 miles, you can't do any more. It's still there. It's still more. The same with the caps. It's like if I'm building, let's say, a power supply, a audio amplifier, whatever I'm building, and I'm sure it will work with like probably like 450, 470 microfarads. I'll put 4,700, yeah, just to be sure. I have a reserve. I have like a buffer. The capacitor is a buffer, yeah. I have a buffer there. So if let's say my main voltage 220 is getting a small drop, that capacitor it will be a buffer. It will keep the voltage. Just an example. It's not the case here. It's always better to have capacitor on the power lines from two reasons. One is buffer. The second is the capacitor it will send to ground any interference. Like switching power supply noises, because you have a lot on the laptop, or different things. But it will work without. Don't worry about that. Everything is done. It's working fine. Okay. So I'll stop this video now and see you probably not next week, the other week. Yeah. Next week I'll be off. We'll see. Maybe we can do some video from home. Yeah, we can. We will go forward with the switching power supplies. Yeah. So thank you for watching. Like and subscribe if you like the video. And see you on the weekend. Yeah. Bye.